Hey guys, we're on lesson 3 of unit 3.3. We're continuing talking about data. If you remember in one of the lessons last week, I mentioned outliers, and we're going to focus a little bit more on that today. To kind of put it in, simple terms, if we have a lot of data that is kind of, grouped all together here, and then there's just one guy that's way over here, that's what we consider an outlier. It changes data, it changes information, it changes, um, averages, medians, all of the information that we're going to find out from all of this stuff. It's going to change just because of this one guy over here that's way, way different than anything else in a data set. So let's go over a few things. So when we describe data by its center, what we're referring to are the measures of the center. Usually it is described as the central or the typical value of the data set. And really all this is talking about is the mean and the median. The mean, of course, we know is the average, and then the median is just the middle number. This is something going back to middle school, even before that. You guys should be pretty comfortable with simple concepts like mean and median. If you're not, no biggie. The mean or the average is the sum of the values divided by the number of values in a set. And of course, again, that's our average. So basically with mean, we add up all the numbers and divide it by however many numbers there are. That's what it looks like here. 1, 2, 3, 4, 5, 6 numbers. So we add them all together, divide by 6, and we get our average. With a median, we're going to just put all the numbers in order and then just pick the middle one. So here, they put it all in order. They see that there's 2 middle numbers, so you then have to take the average. So just in case you forgot or it's been a while, that's kind of the basics of that. With this first example, it just kind of wants you to go over what do you notice about the mean and what do you notice about the median for each of these 3 examples. So this first one is talking about the number of pets, and all of these are dot plots. So if you kind of look at this, all of the groupings, it's mostly grouped over here on the left, right? And then there's a few over here, but mostly it's over here on the left. And what this means is 2 things. It means that the mean, the average, is going to be greater than the median. So basically, if you take the average all of this, because of all of these outliers over here, the average is actually going to be higher than the middle number. The middle number is probably somewhere in here. If we look at this guy here, we notice that there's kind of a, it's pretty even, right? And it's a little different over here. There's 2 instead of 1, but generally it starts low, it goes to high, and then it goes back to low, right? So when there is something like this, the mean and the median, they're going to be about equal to each other. Now, they might not be exact, but they'll be pretty close. Now, this guy over here, as we see, we start low, and then we get kind of high, right? So everything is kind of grouped over here on the right. Usually when this is the case, it's kind of the opposite of over here. Here, the median is actually going to be greater than the mean, the average. So that's going to be kind of what we're answering questions about, is looking at data and saying, like, how does the mean and the median correlate with one another? Are they different? Are they similar? And it's also going to talk about outliers. So like, if a bunch of information is added right here, how does that affect things? So let's keep going. So this information here, think of it as a little bit of vocabulary. The key terms here to keep in mind is symmetrical and not symmetrical. Those are the two key kind of terms here. It's also talking about skewed data. Skewed data is just when something's a little off. You know, it's not perfect. There's something that's affecting the data. So remember when I showed you this guy? This one right here, because it's even, it's kind of balanced, it's symmetrical. So when the distribution is nearly symmetrical, where it's very even, it's almost mirrored, the mean and the median is approximately equal. So here, the mean and the median are about equal to one another. When something is symmetrical, the mean is the appropriate choice for describing a typical value for the distribution. So remember this, if it's symmetrical, we're going to use the mean as the typical value. Now, the opposite is also true. Something that is not symmetrical is when something is skewed, whether it be left or right. So if it's not symmetrical, we're actually going to use the median. The median will describe the data a little bit better. So keep these two things in mind. They're going to be, you know, probably the answers to a lot of questions that you're going to see in our assignments and on our tests. So keep these two things in mind. I also just want to point out something else on here. So symmetrical is when we have a balance, right? Now, when all of the data is over here, that's going to the right, it's actually a little weird. You would think that if all the data was more on the right side, it would be a skew to the right, but it's actually a skew to the left. Almost think about this, like think of like a roller coaster. So we're going down this way, right? So you're and then you go, woo. So that's a left skew. You're going to see that term as a description. So left skewed means that all the data is mostly on the right and you're going down this way. Now the opposite is true over here. If most of my data is over here on the left, then we go down. That is a skew to the right. Now, talking about the outliers a little bit more. An outlier is a value in a data set that is much greater or much less than most of the other values in the set. So basically, it's just something a little bit out of the ordinary. With this example, and you know, it's giving us a situation. There's a day at Disney, a group of students were asked how many times they each rode Space Mountain, which is probably never true because the line for that ride is like hours and hours and hours. So you could probably go on it once and that's about it. Anyway, it wants us to create a dot plot. So I'm just going to go through here real quick and create this dot plot. So I'm just going to keep track. So there's a 4, a 3, 19. That doesn't even make sense. Somebody was probably lying there. 1, 2, and 2. 4 and 3. Another one for 4. Another one for 3. 5, 3. 4, 5, 4, and 5. So where was I? 4, 5, 4, 5. Okay, so here's our dot plot. As you notice, most of the data is here, right? Then we have this one guy here. This right here is our outlier. It's the one that's way bigger than all the rest. It's probably a lie. And that answers this part B. Are there any outliers? Of course, it's right here. Somebody probably didn't ride this ride 19 times, but they might have, who knows? So because of this, the outlier right here, because this number is so much bigger than everything else, it causes the mean the average to be greater than the median. The median's probably somewhere around here. And, if we only had this data, it would be, the mean and the median would be somewhere around here. But because we have this 19, the average is actually going to probably be somewhere closer to like 5 or so. So the median's about here, the average would be about here. It might actually be higher because that is so much bigger than everything else. So that's how an outlier can affect a bunch of data. Okay, so this is just kind of going over a little bit of what we did last week. This is talking about the spread of the data, the measure of spread, which describes how the data values vary or spread out from the center. So all of these are basically talking about the center of something, and then how is it spread from that center. Now with range, it's basically just taking the minimum and the maximum and finding, what is the difference between the two. 16 to 13, there is a range of 3. So this is where we take our max and we subtract it by our minimum. Interquartile range. This is something we did in the last lesson. I had a lot of questions from you guys about this stuff because it is a little bit complicated. This is when we're dealing with the box plots. And basically when you find your Q3, basically the middle of the upper half, which is right about here, we're going to then subtract the middle of the lower half, which is our Q1. So the interquartile range, it's similar to the range, but we're going to use Q3 and Q1 to find that number. Standard deviation is something that is being introduced to you guys, but we're not going to focus too much on it. It gets really complicated. Not going to lie on that. So standard deviation is the average of the distances between individual data. So it's basically saying like, here's all of this data. What is the average in between here and here, and here and here, and here and here, and here and here, and then here and here? It's super complicated. There's a lot of numbers. A lot of times, like a computer will just kind of run these numbers for you. It's something that you're not really going to be asked to calculate just yet. But in higher level math classes, you're going to see this a lot. Especially if you go into any kind of data analysis careers or classes or do anything that deals with computers and engineering and stuff like that. Okay, we're almost done, guys, I promise. So this is one more example, and it's asking us to find the measures of center, so the mean, the median. Then it's asking us to find the standard deviation, which of course it already gave us. It's not going to ask you to calculate it. It's going to find the IQR, the interquartile range, and then just the range itself. Now the good thing here, we already have all this data in order. It's even given you a dot plot. So this should be easy to quickly calculate this sort of stuff. Just for context, the company employs 12 people. Their annual salaries in thousands of dollars are given below. So 25 is 25,000, 30,000, 35,000, 35,000, so on. So, okay. So to find the mean, we're going to take all of these, add them up, and then divide it by 12, because there's 12 numbers, right? So if I just find my calculator real quick. So because I know all of these are in thousands, I'm just going to keep that in mind. So I can just use these numbers. So I have 25 plus 30 plus 35 plus 35 plus 35 plus 40 plus 40 plus 40 plus 45 plus 45 plus 50 plus 60. I get 480. I'm going to divide that by my 12, and I'm going to get 40. So my average is going to be 40,000. Don't forget to keep that in mind. This is in thousands of dollars. So if you're talking about money, $40,000 is the average that everybody in this company makes. For median, we're just going to find that middle number. So one way to do this is kind of how I learned when I was a kid. You just sort of go back and forth, until you see that these two are your middle. If they're the same number, we can just go ahead and say that's the same. Now, IQR is going to be a little bit harder. We have to look at this and sort of make a box plot. We know that this is our min and that's our max. We already found our median. Now we need to find the numbers that are right in the middle of the upper half and the lower half. So if we look at this, look at your median, look at your max. You have 4 numbers, right? So the middle is going to be right here. Those are your middle two. It's sort of like right here, right? But we have to take the average between the two. So because they're the same number, that is going to just give you 45 as our Q3. Now we're going to do the same thing over here. And oh look, we find the same situation happens. 35 and 35 means 35, and that's going to be our Q1. So to find the IQR, we take our Q3 and we subtract Q1. So for IQR, it's Q3 minus Q1, which is 45 minus 35, which is 10, right? So that's 10,000. Now the range, that's where we take our max and we subtract our min. 60 minus 25. And what does that get us? 35, right? So the range of the entire set of data from the lowest paid person to the highest is $35,000. Now, the second part of this is saying, if the list of annual salaries that we just found also includes the owner salary, which is a lot more than anybody else makes, making it an outlier right here, an outlier, what happens? So it's asking us the same question, so we got to go through the whole process again. So get my calculator. Okay, so here we have, I think 13, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, yep, 13. So I don't remember what our number was when we added stuff, so I'm just going to do it again. So 25 plus 30 plus 35 plus 35 plus 35 plus 40 plus 40 plus 40. 45 and 45, 50 and 60, but then we have this 150 in there. I get 630, I'm going to divide that by 13. And did I do that right? Let's see. Yeah, so remember, this is in thousands, so it's 48,400 and say 60, let's round up, $62. Now, the median, we're going to do just like we did before. If we have 13, another quicker way to do that, take 13, cut 13 and a half, what do you get? You get 6.5, right? So you should have 1, 2, 3, 4, 5, 6 on this side, making this our median at 40, just to make sure. 1, 2, 3, 4, 5, 6. So this guy right here is our median. Of course, this is my min, that's my max. Let me write this down. Now it's asking us the IQR and the range. For IQR, we need to find our Q1, which is somewhere in here, and our Q3. So if I have 6 numbers here, sorry, in between my median and my min, I have 1, 2, 3, 4, 5, right? So the middle of 5 is going to be the third number, which is at 35 right there. The middle of this guy, 1, 2, 3, 4, 5, is at 45 right there. Ooh, I did that wrong, didn't I? Okay, so real quick. Because there's 1, 2, 3, 4, 5, 6. I kept forgetting about that outlier. I was still back over here. So we have 6, right? The middle of 6 is going to be 3, right? So we have to find the average of 45 and 50 because like 1, 2, 1, 2, median. 1, 2, 1, 2, 1, 2. That's how we find our Q1 and our Q3 for something that has an odd number of data sets. So we need to find the average of this guy real quick. So 45 plus 50, and then we just divide that by 2. 47.5. So for IQR, and then of course that's just going to give me 35, right? Minus 35, that's 12.5. Now remember, 12.5 means 12. 12,500. Now the range is going to be pretty easy. It's just a subtraction problem. We have 150 and we have 25. That gives us 125, which is 125,000. Now, when we look at this, you know, the IQR changes because of this outlier. The range also changes. The median stays the same, but the mean changes. And that goes back to the example I showed before. If I have an outlier that's way out here, the average is going to change, but the median generally stays the same. It depends on the data. One more thing, and that's basically just going over what I just explained. How is each statistic affected by this outlier? So, I wonder if I can get this all on one slide. Oh yeah, there we go. So we just talked about the mean. The mean increased with the outlier. The median stayed the same. The standard deviation is actually, this is not correct. It should be 31,779 according to my other paper. Yeah, right down here it's correct. I'm sorry. So the standard deviation, of course, goes up because that number, that average in between this guy and this guy goes up significantly. So that's why that number is significantly bigger. For our IQR interquartile range, we go from 10,000 to 12,500. So this one increased. And then if we look at the range, this number and this number, it also increased. So that's basically everything that I wanted to go over. I have no idea how long I've been talking for, but hopefully it's shorter than the last lessons. It's amazing how much information I'm supposed to give you guys for this stuff. But if you have any questions, I'll be on my office hours in Big Blue button, 12 to 3 tomorrow. I'm not always on there for the entire 3 hours, but if you missed me, you can always email me or Canvas message me or any other way to contact me. Other than that, I'm going to keep the Khan Academy lessons a little bit shorter, and then we're going to try to do a test at the end of this week. I am still working on exactly how that test is working, but I will let you know in the next day or two. Okay, thanks guys.